So hello everyone, welcome to the channel. So in this video, I'm going to show you how to estimate a leaf area index and NDVI time series analysis using Landsat imagery in Google Earth Engine. So now let's get started. So to perform a leaf area index and normalized difference vegetation index time series analysis using Landsat 8 imagery. So first we have to define our region of interest and we have to specify the time span where we're going to perform our analysis to identify the change in the trends in leaf area index and NDVI. So first to compute enhanced vegetation index, which is used to estimate the LAI, that is leaf area index. These vegetation indexes are critical for monitoring vegetation health, biomass and land cover changes over time. So the results are visualized in the time series chart and we're going to export our leaf area index and NDVI image to our Google Drive. So first let us focus on what is a leaf area index is. So it is a dimensionless quantity that represents the total one-sided area of leaf tissues per unit ground surface. It is a key biophysical parameter used to assess the vegetation structure and function. So LAI is widely used in ecological studies, agriculture, climate modeling to estimate the photosynthesis, evapotranspiration and carbon sequestration. So LAI is derived from enhanced vegetation index using the below given formula, that is LAI equals to 3.618 multiplying enhanced vegetation index minus 0.118. It's going to give us a leaf area index. Similarly, to compute enhanced vegetation index, EVI is an optimized vegetation index designed to enhance the vegetation signal by reducing the atmospheric and soil background influence. It is particularly useful in regions with a dense vegetation. So EVI improves the sensitivity to high biomass region and minimizes the saturation effects compared to NDVI. So formula to compute the enhanced vegetation index is EVI equals to 2.5 multiplying NIR minus red divided by NIR plus 6 multiplying red band minus 7.5 multiplying blue band plus 1. So the NIR which represents the near infrared band. So let me get back to Earth Engine. So first we have to define our region of interest. So to define our region of interest, we're going to navigate this option called draw a rectangle. So you can navigate to any part of your study region and you can click this option called draw a rectangle and you can draw your study region using this particular tool called draw a rectangle. So now I have managed to create a region of interest for my study region. So once you created your study region, I'm going to click this option called exit. So I'm going to navigate to this option here, show generated code. So here you can able to visualize the latitude and longitude of the study region. So I'm going to copy this latitude and longitude and I'm going to paste it here using Ctrl V in your keyboard. So once you did that, we are ready to proceed our analysis on our study region. So let me turn this off. So first we have to define our region of interest. So we have managed to copy and paste our latitude and longitude. Now let us convert this latitude and longitude into a polygon. So to do that, we're going to define a variable called region of interest ROI equals to earthengine.geometry.polygon. And we have copied our latitude and longitude of our study region. Next, to center this particular layer, we're going to define map.center object region of interest with a specific or the suitable zoom level. And next, to add this layer, we're going to define map.addLayer region of interest with the default visualization parameter and we're going to output the layer name as study area. So to proceed our analysis, we're going to calculate the leaf area index and NDVI time series analysis. So first we have to define our time span, the suitable time period. So where we're going to start our analysis and where we're going to end our analysis. So let us define our time range. So to define our time range, we have defined this variable called start date equals to earthengine.date. So we're going to mention as 2014 January 1 and the end date we're going to define by variable end date equals to earthengine.date 2024 December 31st. So now we have managed to mention the start and end date starting from 2014 January 1 to 2024 December 31st. So next, so to perform our analysis, we're going to load our Landsat 8 image into Earth Engine. So to do that, we're going to define this variable Landsat collection equals to Earth Engine dot image collection Landsat LC8 collection to tire L2. So using the specific code, we can able to access our Landsat 8 imagery. So let me show you this particular dataset. So USGS Landsat 8 level 2 collection 2 tire 1. So the dataset availability is from 2013 to 2025 and the dataset provider is USGS. So using this particular script, we can access this particular satellite dataset. And these are the following bands that is available in this particular dataset. So the resolution of this particular bands are 30 meter, starting from SRB1 to SRB7. And the ST band, which represents the thermal band and Landsat 8 image. So now let us get back to Earth Engine. So to access this particular Landsat 8 image, we define Earth Engine dot image collection Landsat LC8 collection 2 tire 1 L2. So next we're going to filter with a specific timeline. So to perform our analysis, we're going to filter with a specific timeline. So for that, we're going to mention dot filter date, start date and end date. So the start date we have mentioned as 2014 January 1 and the end date we have mentioned as 2024 December 31st. And next we're going to filter is based on our region of interest. So for that, we're going to define dot filter bound ROI, which represents our region of interest. So next we're going to filter it based on the least cloud contamination. So for that, we're going to define dot filter the Earth Engine dot filter dot less than cloud cover of 10. So we're going to filter the land cover Landsat 8 image with the cloud contamination less than 10. And next, to perform our analysis, we're going to select this following set of bands. For example, we're going to select SRB2, SRB3 and SRB5 to perform our analysis to calculate NDVI and leaf area index. So for that, we're going to select this following set of band, that is SRB2, SRB4 and SRB5. So the B2, which represents the band 2 of blue surface reflectance, and B4, the band 4 of red surface reflectance, and B5, that is band 5 of near infrared surface reflectance. So next we're going to create a function to compute NDVI and LAI, that is Normalized Difference Vegetation Index and Leaf Area Index. So to compute NDVI and Leaf Area Index, we're going to define a variable compute vegetation indices equals to. So we're going to create a loop function to calculate the NDVI and Leaf Area Index. So for that, we're going to define equals to function image, and in that we're going to create another variable in order to apply the scaling factor for Landsat 8 imagery. So we can able to visualize here we have the scaling factor of 2.75 into 10 power minus 5, and we have this offset value of minus 0.2. So we have to apply the scaling factor. So for that, we're going to define a variable scale bands. So we're going to define variable scale bands, scaled band equals to image.select. So we're going to select SRB2, SRB4 and SRB5 to apply the scaling and offset value. So we're going to apply this particular. To do that, we're going to define dot multiply 0.00000275. So this is the scale factor, and similarly we're going to apply the offset factor. So the offset factor we're going to apply as a dot add minus 0.2. So next we can proceed towards computing of analysis to compute Normalized Difference Vegetation Index. So for that, we're going to define a variable NDVI equals to the scaled band dot normalized difference SRB5 and SRB4, that is SRB5 minus SRB4 divided by SRB5 plus SRB4. And we're going to rename as that is a formula to calculate the Normalized Difference Vegetation Index, and we're going to rename the layer as NDVI. And next we're going to compute enhanced vegetation index. So first in order to compute the leaf area index, first we have to calculate the enhanced vegetation index as I said earlier. So let me show you that. So to calculate the leaf area index, first we have to compute enhanced vegetation index. So for that, we're going to compute enhanced vegetation index. So to compute EVI, so we define a variable EVI equals to the scaled band dot expression. So we're gonna mention the formula to calculate the enhanced vegetation index, that is 2.5 multiplying NIR minus red divided by NIR plus 6 multiplying red band minus 7.5 multiplying blue plus 1. So this particular formula is used to calculate the enhanced vegetation index. Next, we have to connect this NIR with the SRB5 band. So for that, we're going to mention NIR is we're going to mention a scale band dot select SRB5. So NIR will be SRB5, and similarly the red band, the scale band dot select, we're going to select to SRB4, and for the blue band we're going to mention as scale band dot select SRB2. So to compute our enhanced vegetation index. So once you did that, next we're going to navigate to compute our leaf area index using enhanced vegetation index. So to compute the leaf area index equals to, first we're going to define enhanced vegetation dot expression. So we're going to apply this formula to calculate the leaf area index. So that is 3.618 multiplying EVI minus 0.118. So this is the formula to calculate the leaf area index. And in that we're going to specify the EVI. So the formula we have specified EVI, capital EVI is we're going to specify at this particular variable EVI. So we have mentioned here to calculate the enhanced vegetation index. And last, once we apply this formula, we're going to rename as leaf area index. So once we had performed our analysis, the formulas to compute NDVI and EVI and leaf area index. So we're going to return the image, and we're going to mention dot add band NDVI dot add band LAI, that is leaf area index. So we're going to add the following this set of bands we have created NDVI into our image. So NDVI LAI leaf area index. And the copy properties, we're going to mention the system start time and system index. So in our next stage, we have to apply this computation to our Landsat image collection. So for that, we're going to mention variable vegetation collection equals to the Landsat collection dot map compute vegetation indices. So compute vegetation indices within this particular variable, we have computed all this NDVI, EVI and leaf area index. You can able to see. So under this loop function, we have computed NDVI, EVI and leaf area index. So next we're going to generate a time series chart for NDVI from 2015 to 2022. So let us create a chart to compute the NDVI time series analysis from 2015 to 2022. So for that, we're going to define print ui.chart.image.series, and the image collection we're going to refer over in the vegetation collection. And in that, we have we're going to select this particular band called NDVI. And the region is our region of interest. So we have created earlier. So that is our study region. So this is our study region. This is our study region. And we're going to apply the reducer function, a statistical function, in order to acquire a mean image. So we have this variety of different image for this specific set of duration. So to acquire a mean image for this particular month, in the year, so we have to compute the statistical function. So for that, we're going to define dot earth engine dot reducer dot mean function to acquire a mean image for this particular month. For example, I'm going to acquire a mean image for January. So I'm going to use this particular function dot mean function. And the spatial resolution, you can set, it's up to your choice. I have set to 500 meter of resolution. In order to increase the speed of this computation, I have mentioned the scale. So you can also reduce the scale to 100, and you can view the result more clearly. So for the computation time purposes, I have increased the resolution to 500 meters. And next, we're going to mention as the set options. So for example, in this axis, so I can mention as NDVI in this axis, and this axis I'm going to mention as year. So for that, we have to apply this function called dot set options title NDVI time series 2015 to 2022, and the h-axis is year. This is the h-axis, and the v-axis is NDVI. So this is this axis is NDVI, and you can also specify the line width. So this particular line width, so mentioned as 2, and also the color of this particular line I mentioned as green. And similarly, to generate the time series chart for leaf area index, so we're going to use the similar set of functions, print ui.chart.image.series, and the image collection, we're going to mention vegetation collection, and in that we're going to select LAI, that is leaf area index, and the region is region of interest, that is our study region. So we have created to node that is of a study region we have created in the first step. And we have to apply the reducer to acquire mean image. So we're going to mention Earth Engine reducer dot mean function, and the scale, so 500 meters. So increase the speed of computation, I've mentioned is 500 kilometer. And X property, that is system start time, so the time start of an analysis from 2015. And to set options similar to in this axis, we can set our axis title for this analysis, this chart. So for that, we're going to apply this function dot set options title LAI, that is time leaf area index time series from 2015 to 2022. And the h-axis we're going to mention as year, and the v-axis we have mentioned as leaf area index. And the line width I have mentioned the size of 2, and the color I have mentioned blue. And last, to visualize a specific set of image, for example, so I'm going to extract NDVI image and leaf area index image for the specific year in 2020. So to do that, to acquire a specific year NDVI and LAI image, I'm going to define this variable NDVI 2020. So in that, I'm going to specify that is variable NDVI 2020 equals to vegetation collection, referring to our the Landsat 8 image collection. So let me show you that. So referring to this particular variable, so you can able to see that vegetation collection. And in that, I'm going to filter with a specific time. For example, in my case, I need this particular year NDVI and LAI image. So mentioned as 2020 January 1 to 2020 December 31st. And once you mentioned your timeline of your choice, for example, I mentioned 2020 January to December. So you can also select year of your choice. For example, you can select from 2014 or 2018 or 2024. It's choice yours. So next, to acquire a median image. So we are using we are applying the statistical function median function to acquire a median image. For example, in case of mean function, we have some extreme values. So we have extreme values in case of mean function. So to acquire to avoid those extreme values, we can use this function called median function. So for that, we are using the statistical operation dot median function and dot select NDVI. And similarly, to compute to extract leaf area index for the specific time 2020 January 1 to 2020 December 31st, we're going to define this variable LAI leaf area index 2020 equals to vegetation collection dot filter date. We're going to mention the time period 2021 January 1 2020 December 31st, and dot we're going to apply a median function to compute a median image. And we're going to select LAI band. So in the previously we have managed to add this band in our Landsat collection after we performed our loop function. And last, to visualize this particular layer in different colors, so we have to set the visualization parameter. So for that we're going to define this variable NDVI which represents the visualization parameter, and we're going to set a minimum of -1 and a maximum of +1. So the -1, which usually indicates the non-vegetation areas, and the +1, which indicates the vegetation areas. So these are the following set of color bands to represent the NDVI changes. For example, the brown, which indicates, so the positive one, which indicates the vegetated areas. So the green, which indicates the vegetation areas. Similarly, so the variable LAI, which represents the leaf area index visualization parameter, and we're going to set a minimum of 0 and a maximum of 5. So for the interpretation purposes, in case of a leaf area index, let me show you this value. So the value of 0 to 1, the spare or no vegetation. For example, it indicates the bare soil, desert or urban areas. So the value ranging from 1 to 3, it indicates low to moderate vegetation cover. For example, grassland, the shrubs or young crops. If the value ranges from 3 to 6, it indicates a dense vegetation cover. For example, mature crops, deciduous forest. Or if the value greater than 6, which represents the very dense vegetation like tropical rainforest or the dense coniferous forest. So let me get back to Earth Engine. So now to add this layer into Earth Engine, so we're going to define map.addLayer NDVI 2020. So we are referring to the variable NDVI 2020, this particular variable. and dot, we're going to clip based on our region of interest, that is our study region. And we're going to set the visualization parameter for our NDVI image. So it's referring to this particular variable, and output the layer name as NDVI 2020. And similarly, to add LAI, that is leaf area index, we're going to define map.addLayer leaf area index 2020 dot clip region of interest, which represents our study region. And with the visualization, so we can refer this particular variable for the visualization purposes, and we're going to output the layer name as LAI 2020. So now let us run this code, and let us visualize the result. We can navigate to the run script and click run script. So now we're going to turn to a satellite mode here. So in the layers, we have a study area, NDVI 2020, and NDVI LAI, that is leaf area index 2020. So first let us visualize the NDVI image. So this is our NDVI image. So I'm going to navigate to the layer section, and in that I'm going to click this option. So the NDVI value ranges from -1 to +1. So I'm going to apply some custom stretch here. I'm going to click stretch 90%, and I'm going to click apply. So now we can able to visualize the result. So the value ranges from -0.32 or to 0 plus 0.6. So the positive value, which indicates the vegetated areas, and the negative values, which indicates the non-vegetated areas. For example, so you can able to visualize this is the water body, which is clearly highlighted in NDVI image. So you can able to see that. And similarly, the spare vegetation or no vegetations are indicated in this set of color, in yellowish color, and all the vegetated areas are clearly highlighted in the green color, you can able to see. And similarly, I'm going to turn on the leaf area index. So this is the leaf area index. Similarly, I'm going to apply the stretch type for our leaf area index image. So I'm going to navigate to the custom section here, and I'm going to click this option called stretch 90%, and I'm going to click apply. So you can also add more color to it, but we're going to fix and we're going to compare the NDVI with LAI. So I'm going to click apply. So this is the leaf area index. So we have managed to compute the leaf area index using enhanced vegetation index. So you can able to see the clear difference here. So the value ranges from -0.081 to +1.8. So the higher positive value, which indicates the dense vegetation. For example, so this is the interpretation value. So if the value is from 0 to 1, it is spare or no vegetation. So if it is from 1 to 3, it is low to moderate vegetation cover. So in this, you can able to see the value ranges from -0.081 to +1.8. So the mostly the vegetation in this area, which occurs as a low to moderate vegetation cover, probably the grassland or the young crops. So now I'm going to close this, and let us visualize our time series analysis. So you can able to see here, we have this is our time series analysis. So the NDVI trends has been clearly observed in this image. So I'm going to click this option. So this is the NDVI trend from 2015 to 2024. So you can able to see that. So the highest NDVI value was observed during this particular month in July, and the lowest NDVI value was observed in November. You can able to see for the specific study region. And similarly, the NDVI value was lowest during this particular month in December, and highest it was observed in June. So similar trend was observed in the entire time period. You can able to see here. So you can able to see here there is the time series analysis for leaf area index. So you can able to see in this axis we have a leaf area index, and in this axis we have in year, and the two peak value which can be we can observe here kind of which indicates anomaly, and the value is a bit higher here. So probably some extreme values might have caused this particular error. So let us try to resolve this particular error. So instead of using a mean function in this time series chart, gonna mention as a median function, and let us visualize the result for leaf area index. So now I have mentioned as median function, and let us run this code, and let us visualize the result for our time series chart for leaf area index. And let me check this. And the first chart is our NDVI time series chart, and the second chart is our leaf area index. So now I can able to visualize we have managed to resolve the error we are facing. So instead of mean function, I've used median function. So mean function is most some cases the extreme values can be observed in the using mean function. So to avoid that, we are using this median function. Now it's kind of correct. It's giving us a correct value. So I'm gonna click this option here, and we're gonna visualize the graph in detail. So we can able to see the leaf area index value has been ranging from a lowest value for around so you can able to see it is around minus 6.09 to a highest value of around 16.4 in 2022. So based on our interpretation value here, so if the value is falls between 0 to 1, it is spare or no vegetation, and the value is falling from 1 to 3, it indicates low to moderate vegetation cover. And if it falls in 3 to 6, it indicates the dense vegetation cover, the mature crops, and in case if it is more than 6, it indicates very dense vegetation, the tropical rainforest or dense coniferous forest. So let me get back to Earth Engine. So you can able to visualize this value here. These are the leaf area index for this specific study region over the time period from 2015 to 2024. You can able to see, and also you can download this particular as a CSV file. So you can download it as a CSV file here using this. You can click this option and you can download as a CSV. So let me get back to Earth Engine. So we have visualized the image and as well as we have seen the time series analysis for NDVI and leaf area index. And last, we have to export our NDVI of 2020 and leaf area index of 2020 image to our Google Drive. So to do that, we're going to define export.image.drive image NDVI 2020.clip ROI, and description we're going to mention as NDVI 2020 analysis, and spatial resolution. So we can adjust this particular data set. It is of Landsat 8 image. So I'm going to reduce the scale to 30 meter resolution. And similarly, I'm going to export this at 30 meter resolution. So you can also increase the scale spatial resolution. But in case it will take a longer time to export this particular image to your drive. So currently I set to 30 meters for both the NDVI and leaf area index 2020 image. So we have to mention export.image.drive, and image I'm gonna mention as NDVI 20 clip, and description is NDVI 2020 analysis, spatial resolution, and the region is ROI, that is study region, and coordinate reference system, and the folder, and the max pixel value, similar to the above mentioned for leaf area index. So after that, we're gonna click this option called run, and we're gonna navigate to this option in the task section. So it's loading now. So now we're gonna navigate to the task section here, and you can able to see here we have two tasks called unsubmitted task, NDVI 2020 analysis and LAI 2020 analysis. So to export this image to a drive, so for first to export the NDVI and leaf area index image to a drive, we're gonna click this option called run in both the cases for NDVI as well as leaf area index. So a window pop-up saying initiate image export, so task name and the coordinate reference system and the spatial resolution. So we can export to a drive and in GeoTIFF file format, and you got to click this option called run. So to export to your Google Drive, you can also export this image to your cloud storage or Earth Engine asset, and we have currently select to drive, and we can click this option run to export this image. Similar, so leaf area index, we have to click this run option, and a similar window will pop up. We have to see it is in GeoTIFF file format, and to export to a drive, you have to click run. So in this video, I have shown you how to estimate the leaf area index and NDVI time series analysis using Landsat imagery in Google Earth Engine, and the code will be given in the description. And make sure that you subscribe to our channel and give us a like. So thanks for watching, and make sure that you subscribe to our channel and give us a like.